Hello, in this episode, we'll go over the deep convolutional GAN and compare it with a vanilla GAN. Since we have seen many GAN, we'll not go into detail of the code, but rather just compare the main differences. So here is a vanilla GAN. As usual, we import the TensorFlow libraries and set the image. The image shape is 28 by 28 by 1 channel, and the generator takes 100 random variables. The latent dimension is 100. So the generator takes 128 dense layer, and then eventually outputs 784 nodes as a fake image. Okay. And the discriminator basically get the 784. We flatten the input shape 28 by 28 by 1 into 784, and then goes to the dense layer eventually to one node to get the true and fake and real decision. The GAN takes the generator and then puts the discriminator, that's the GAN model. We build the discriminator and then the generator, fix the weight and build the GAN. Right. The training is also, we have seen before, except maybe you can scale from divided by 255 to scale the pixel values to 0 to 1. But instead of that, we just divide it by 127.5 minus 1, mean the pixel scale from -1 to 1. Either way, it's fine. The real labels are 1, fake labels are 0. So we give the real, train the discriminator by the real and fake data, and then generate fake and fake data and tell it it's real to the discriminator with fixed weight to train the generator. So this is the typical GAN that you can do, and you can see that it eventually trains, initially starting with a very crude image, where it is, like this, but eventually it will get better, as you know, like this. And you can see the training loss and accuracy. So this is vanilla GAN. So how does that differ for DCGAN, the deep convolutional GAN? So we keep pretty much everything the same, the libraries, the parameters, but look here, the generator. So you have a sequential, and then we go here, the generator have some random numbers coming in, and we basically do what we call a transpose convolutional layer, which upscales the images, eventually putting out an image that will be given to the discriminator. The discriminator in turn takes that image, and now we are using a convolutional layer and that will screen through the 28 by 28 image for each data point. Okay? And we have actually multiple layers of that, so this is how you call them. And shrink it down and shrink it down. And eventually the discriminator job is to have one node and say whether it's true or fake, of course. And the DCGAN part, the GAN is actually the same as before. You just have the generator and the discriminator. We build it, build the generator, fix the trainable weight of the discriminator, and then have the GAN model. The training loop is pretty much the same, isn't it? We train the discriminator to the real and fake data, and then train the GAN, meaning we give a random number, feed it to the generator, and then to the discriminator with a fixed weight, but tell the discriminator it's a real data and train it. So this is pretty much all the same as before, and you can train it. So the point is that the DCGAN is not too different from a vanilla GAN, except that the generator and discriminator structures use different layers of neural networks. So that was the only difference. The codes run about half an hour, so I'm not going to run it here, but the main difference was basically these small step in the generator and discriminator components. So this was about how vanilla GAN and DCGAN differs. Thank you for watching this episode.